Hello, this video is about the Jointplot function in Seaborn. Jointplot plots the joint distribution of two variables, so let's make ourselves a random model. We have two dependent variables. One will be noise and one will be the known quantity, and a linear relationship to y. This is what it looks like with the default parameters. There are several different variations on this plot. You can pick which one you want with the kind variable. The default is scatter. This is a regression. Reg will draw a regression line through the data. Resid for residual will show us just the noise. KDE gives us a kernel density estimate. Hex uses the hexbin function of matplotlib to show us what is essentially a histogram. You can change the size of the plot with height. It always comes out to be square, so height is also width. Color has the obvious effect. There's this parameter called space, which puts a little bit of a buffer between the marginal distribution plots and the joint distribution plot. You can see that the axes have been normalized here, so slope of the line appears to be almost exactly 45 degrees. But I can use these xlim and ylim parameters to set the scales to whatever I want. Here's what the graph looks like when the two axes use the same scale. When the kind is set to scatter, the joint distribution is plotted with matplotlib's scatter function. I can adjust its parameters using the joint KWS parameter to joint plot. So for instance, if instead of having a single color, I wanted the color to vary based on some third variable, or if I wanted to change the marker style, I could do that by passing keywords to joint KWS. I should say something about the difference between joint plot and joint grid. Joint plot creates a joint grid with some obvious defaults, so most of these keyword arguments won't work well because they have been overridden. For instance, you can see here that I've had to clear the color parameter so that the C parameter would take. In this video, I will show you the few that work well with joint plot, but in many cases you will want to use joint grid, which I will cover in the next video. The regression plot allows not just for lines, but for fitting any polynomial. So if our model was, say, a function of the square of x rather than just linear and x, we could change the regression plot by using the order parameter. So here I can see that I'm fitting to a parabola now and not just a line. The default behavior for the hex bins is to show the density of data points in each grid element. But I can hand it a third variable using this C parameter, and it will average over that instead. This is similar to the lowercase c in the scatter plot. The marginal keywords variable affects the marginal distribution plots along the side. This is simply a call to dist plot, which I covered in the previous video. So if you have any keywords that you would have passed to dist plot to adjust its behavior, you can pass them to marginal KWS.